Comparing theoretical and experimental probabilities. So let's have a look at this spinner. So the spinner has numbers 1, 2, 3 and 4 on it, and it is a fair spinner. That means it's equally likely to land on any of the numbers. It is spun 150 times and the results are below. So it landed on a 1 40 times, a 2 41 times, a 3 37 times and a 4 32 times. And what we have to do is we need to calculate the experimental probability and then compare it to the theoretical probability. So first of all, we have our formula. So experimental probability is the number of successful trials for each number divided by the total number of trials. So for each number, we're going to work out its experimental probability. So for number 1, it had 40 successful trials out of 150. The number 2 had 41 out of 150 trials. 3 had 37 successful trials out of a total 150. And 4 had 32 out of a possible 150 trials. Now when you're comparing theoretical and experimental probability, it's most useful to use decimals as your answers. So instead of using fractions, we were going to use decimals. So here are the experimental probabilities that I've worked out. So this is the answer for number 1, which is the same for 2, and then 3 is 0.25 and 4 is 0.21. So next we're going to have to work out the theoretical probability. So remember the formula is the number of favourable outcomes divided by the total outcomes. So if we look at the spinner, there is 1 out of a possible 4, 1 2 out of a possible 4, 1 3 out of a possible 4 outcomes, and 1 4 out of a possible 4 outcomes. So for each number, 1, 2, 3 and 4, the theoretical probability is exactly the same, which is 1 out of 4, a quarter, or as decimals, we have 0.25. So as we can see, the experimental and theoretical probabilities are reasonably close together. Now, as mentioned in a previous clip, the more trials that we undertake, we would expect the experimental and theoretical probabilities to get even closer together. If this does not happen, however, the experiment might be biased. A biased dice, or a biased spinner, means that it's more likely to land on one number than the other, perhaps because it's got weight on one side of it. So let's consider we did the experiment again, and these are results below. Now you can see that the number 1 landed on 65 times, which seems quite a lot. And if we compare the theoretical and experimental probabilities, so we calculate them again, we will get experimental probabilities and theoretical probabilities which are quite different, and this would suggest that there is some bias. However, in order to investigate further, it would be important to increase the number of trials, i.e. the number of spins. Not sure how to answer a question? Pause the video and try this. How did you get on? Here are the answers. If you answered it incorrectly, have a look back through the video and then try again.